Welcome back to Klein's Geometry. We're going to look a little bit further at lesson 8.2. We're going to do one more example of finding a triangle part, and then we're going to look at a little problem solving application. Consider this triangle STU, where we have a 42-degree angle at T, and the hypotenuse is 9.5 inches. What if we want to find ST? We're going to use the same process we used in the last video. The first thing I'm going to do is I'm going to label this my hypotenuse across from my right angle. This is a leg that's attached to the angle, so it's the adjacent leg. And this leg is across from the angle, I know, so it's the opposite leg. So I have the hypotenuse in this case, and I want ST, so I want the adjacent leg. So now I think, what ratio should I use? And I think, SO, CA, TOA. And I want to relate a hypotenuse and an adjacent leg. So I'm going to use the cosine ratio. Once I decide that, I write it down. The cosine of a 42-degree angle equals the adjacent leg, ST, that's the one I don't know, so I just put an ST, over the hypotenuse, 9.5. Now we just solve it. And we remember that cosine of 42 is just a number, so the first thing we do is we multiply by 9.5, that's the opposite of dividing here, and we do the same thing on both sides. That's going to cancel out, and to find my answer, I'm just going to take 9.5 times the cosine of 42 degrees in degree mode. Make sure you're in degree mode. Press enter, and I know that ST is approximately equal to, rounding to the hundredths place, that's 9, so I bump it up, 7.06. So there's my answer. So that's all you're doing with those things. Remember, label the parts of your triangle in relation to the angle you know. Figure out what you have, what you want. SOHCA TOA. Pick out which one you need, and then set it up and solve it. Okay, what if I have a word problem? Okay, let's say I'm a contractor, and I'm building a ramp for a doorway. So here's my doorway. It's up above the ground, and I need a ramp to go up the doorway, and the ramp is 1.2 feet up above the ground, so that's where the house goes. And this is the ground, and this is my ramp, and the ramp makes an angle of 4.8 degrees with the ground. It's some building spec. They have rules about this for handicapped people. So I know that angle has to be 4.8 degrees. What if I want to find the horizontal distance? Well, if I want to find the horizontal distance, I'm looking for the ground here. This is the right angle. So, same process, but you got to draw the picture, so you got to be careful with that. If it says here, here's your clue here. It says ramp makes an angle of 4.8 with the ground. So if you think ramp, ground, you know that's where your angle was, okay? Think about, what do I have and what do I want? Well, I have the leg opposite the angle, and I want the ground, so I want the leg adjacent to my angle. So I think, SO, CA, TOA, and I think, okay, I need to relate O and A. That's TOA. So I am going to, at this point, set up an equation where I have the tangent, that's my TOA, of the opposite of my angle, 4.8, equals the opposite over the adjacent, which is the ground. Now remember from our last video, if you've got the variable in the denominator, these two are just going to change places. So I've got my ground equal to 1.2 divided by the tangent of 4.8. And I can just plug that into the calculator, 1.2 divided by the tangent of 4.8 degrees in degree modes, and I'll get 4.29 feet. That's feet because it was feet up here, okay? Now what if I want to find the length of the ramp? Well, then, if you think, what do I have, and what do I want? I have the opposite side still, but this time I want the hypotenuse. So if you're thinking about your SOHCAHTOA, I need to relate the opposite side to the hypotenuse. And the sine is the one I'm going to use. The sine of 4.8 degrees equals the opposite over the ramp. That's my hypotenuse. And recall again, if this is in the denominator, I can just flip those out. R equals 1.2 over the sine of 4.8. Get out my calculator. Make sure you're always checking your mode. Okay, it's degree, it's good. 1.2 divided by the sine of 4.8. And I end up with the ramp being about 14.34 feet. Now, I expect my ramp to be longer than the ground, because that's the hypotenuse. And I see it is, so life is good. So hope that helps. Enjoy your trigonometry problems, and I will see you in class.